Hello, my name is Joe Phillips. I'm the Vice President of Engineering here at Desktop Metal. I'm here to introduce the S-Max Flex, our newest additive robotic manufacturing 3D printer. The top three things about this machine that you need to know: it's affordable, it's easy to use, and it delivers quality parts. I want to go through the printer in detail now. What we've started with is really a titanium bar. We chose titanium because it has a low coefficient of thermal expansion, so it doesn't change size and shape as the temperature changes in your foundry. Now you get a nice flat continuous plane with a very well-controlled offset between the print head and the bed. That gives you that dimensional accuracy that you're looking for. Right now what you see is the printer's going over to fetch sand, and what you can see underneath the metering hopper is a gated sand depositor. That gated sand depositor very quickly lifts that gate up, deposits sand into the metering hopper and fills it. You can see it only took a couple of seconds to do. That's really to make sure that the speed of the system is optimized. So right now we print at 115 liters per hour, and it's going back to the other side. It's going to lower into its print position, and it's going to start printing again. To my left, you can see our telescoping build box. It's 1 meter wide, 1 meter tall, and 1.9 meters long. That telescoping build box is responsible for containing the sand as you print each layer. It basically indexes as you start printing your parts and you add to your parts. At the top of that, once you get to that 1 meter and you've completed your build, you can then pull the gate valve. The gate valve opens up, all the unbound sand falls out of the bottom, exposing your printed part. And then you remove the printed parts and start your depowdering process. After you print, all the unbound powder is 100% recyclable. It keeps your costs down. So once you extract your printed part, you recycle that sand, sift it, put it back into the system, and you're ready to print. That keeps your part costs down, and your price per cubic inch is very competitive with traditional core shooting. The high level, what you need to remember is this is affordable, easy to use, and produces high quality parts.
Having this machine has showed us a different future in our business.
We're able to produce higher quality parts that have more value added to them, more complex castings for advanced applications. And bringing in technology like 3D printing really augments what our team members can do.
There is a distinct cost advantage to producing the core this way over traditional methods. It cuts a tremendous amount out of the lead time, but there's also the cost of that tooling that is simply eliminated.
It's pretty amazing seeing how far the technology has come in such a short period of time. As the costs of the 3D printing equipment and as the cost of the consumables come down, you are increasingly going to see 3D printing take over a larger percentage of how metal casting companies like us are making molds.
The advantages that it's provided for us and for our customers has been enormous, and it's allowed us to move into all new markets that we hadn't been in. It's fun to come to work every day and to know that we can make nearly anything that we can imagine out of a casting.
You are now in the Shop Lab. The Shop Lab is designed to be a mini factory to continuously exercise the shop system, printing hundreds of parts a day for ourselves and for our customers. So the shop system is the first metal 3D printer designed specifically for machine shops, allowing shops to enter into additive metal manufacturing like never before. The shop system is a single pass, high-resolution metal binder jetting system at a price point that has never been achieved before. The shop system is an extremely easy system for machine shops to learn to use. Powder is loaded into the printer, and the printer autonomously lays down 50 to 100 micron layers of metal powder and prints batches of parts. The customer can load as many different parts as they would like into that batch, and it does not change the time. The printer then ejects that batch of parts, which can move on to the next station, and the printer can begin another batch of parts. The next step in the shop system is the depowder station. Now, the shop system is a batch process, which means a batch of parts can be printed, and then that batch can be moved on to the depowder station, so another batch can then be printed at the same time. The depowder station is a fully integrated depowdering station where parts can be excavated from the powder and that powder can be fully recovered in the integrated recovery system. Those parts, once excavated, can be placed directly into the desktop metal furnace for full sintering. Sintering technology has evolved over the years to be huge furnaces that cost hundreds of thousands of dollars and take up entire rooms like this. But what we've been able to do here at Desktop Metal is shrink down that same technology into a small furnace that is vacuum capable, partial pressure capable, and can roll through a door. And the shop system is designed to scale manufacturing from small scale to medium scale to enhance a machine shop, whether it's an external machine shop or an internal machine shop, with 3D printing capability.
Previously on XJet.
XJet nanoparticle jetting. Welcome to a new era in metal additive manufacturing.
MORI is your comprehensive supplier and full-line supplier both in the area of additive manufacturing of metal components as well as machining post-processing. Within the framework of a completely digitized process chain, we combine all the most important additive manufacturing methods for metal components under one roof. The Lasertec 65 3D Hybrid sets new standards in the powder nozzle process and combines laser metal deposition welding with 5-axis milling operation in one machine. The Lasertec 65 3D Hybrid offers a generously dimensioned additive working area for workpieces up to a diameter of 500 and 400 millimeters in height and a weight of up to 600 kilograms. Controlled by additive and subtractive CAD/CAM programming based on provided customer data, the Lasertec 65 3D Hybrid creates high-quality workpieces within a short period of time and offers almost unlimited possibilities in regard to product design and material. With the new developed Lasertec 65 3D, DMG MORI enlarges the powder nozzle series with a pure additive manufacturing machine, 45% less floor space, and 40% larger working room versus the hybrid version, as well as depositing of reactive materials like aluminum and titanium opens up further possibilities. The second-generation Lasertec 30 SLM is used for additive manufacturing in the powder bed process, rounding off DMG MORI's additive manufacturing product portfolio. With a construction volume of 300 by 300 by 300 millimeters, it supports the high-precision building of workpieces featuring layer thicknesses of between 20 and 100 micrometers. And the replug powder module enables contamination-free material changes in less than 2 hours. This modular changing system reduces the cleaning time, ensures safe handling of materials, and makes it possible to use any additional materials as desired. The app-based user interface, Silos, offers a consistent software solution covering everything from CAM programming with our R-Designer tool through to machine control tasks. This open system also makes it easy to customize all machine settings and process parameters. And with seamless data transfer, allowing pre- and post-processing on the HSC20 Linear and the DMU40 Evo Linear, DMG MORI provides solutions for the entire process chain, from the initial drawing to the finished part. DMG MORI Additive Manufacturing. Reinvent your metal production.